Hello viewers, welcome back to class. I'm super excited to welcome you guys back to class again. This is a wonderful lesson that you will benefit from maximally. Now, if you are new in this channel, do consider subscribing to this channel and ensure that you turn on the post notification bell for more exciting videos when they are uploaded. And guys, don't forget our policy: do not skip any part of this video. This is for your own advantage. And also, do not entertain any form of distractions anytime you are set to learn new concepts from this platform. And finally, if there be any part in this video you do not understand, when you watch it for the very first time, guys, you have the opportunity to replay the video over and over again till you understand. Yes, you can understand it if you take your time to watch the video and pay close attention. But if at the end of watching the video over and over again you still have questions to ask, guys, don't hesitate to dive to the comment section and make your questions known to us. We will reply your questions either in group or individually. Now guys, let's get to it. Don't forget that in this lesson, we are actually looking out for calculus for undergraduate students who offers OBJ objectives in their examination. And as such, we are limited to the use of shortcuts. Of course, it can benefit you if you do not do objective, but let's make these lessons only for objective students so that they can meet up with their examination time and come out in flying colors. Now, on the board, we have computation of limits, and we are looking at computation of limits of quotient functions. And we have the problems before us. We are asked to find the limit of the following functions. And I explained earlier that for quotient functions, you have a numerator and you equally have a denominator. You have a numerator, you have a denominator. And when you have numerator and denominator, the equation or the function you are given can either turn out to exist or do not exist when you impute the limit value that you are given. So what do I do here? For the sake of objective student, now listen, pay close attention, because when you understand principles, you become a principal, and that's the reason why I want to do this for you. Okay? Now listen carefully. Anytime you are given quotient function, do not pay attention to the numerator at all. All you need to do is to pay attention to the denominator. Why? In mathematics, it is accepted to have 0 as a numerator. 0 over 3. But it is not accepted that you have 3 over 0. This is defined. Are you there? Why this is undefined? Now, for defined, this is accepted. So if you impute this value in your calculator, your answer will turn out to be 0. But when you do say with this, impute this in your calculator, you are not going to get 0. You are going to have mathematics error. That's exactly what you are going to have. That is to say, this expression is undefined. So anytime you are dealing with the limit of a function, all you do is pay attention to the denominator. And how do you pay attention to the denominator? What you simply do is to pick out the denominator, then substitute the limit value that you are given. When it gives you 0, listen, when it gives you 0, then you will have to use other methods to solve the problem. What are the methods? You can use L'Hospital method, where you differentiate the functions. You can use factorization method, and you can also use the Thompson rule and many other rules. But in this lesson, we have checked over time that the L'Hospital rule happens to be the simplest and the smartest method for objective students. So in this lesson, we will be using only L'Hospital rule for all defined limit functions. L'Hospital. That's what we are going to be using. And in L'Hospital, all you simply do is to differentiate the functions individually. Of course, by now, you shouldn't have issues with differentiation. And that's the reason why we decided to look at differentiation before looking at the limit of functions. So now, let's get to work. The limit x tends to 2 of x minus 2 over s squared minus 4. Like I explained earlier, this is the first question we have now. All I just need to do here is to bring down the denominator, which is x squared minus 4. Substitute the value of x. Of course, we know that the value of x here is 2. Then this would have given us 2 squared minus 4. And 2 squared would have given us 4. And 4 minus 4 is 0. That makes this expression undefined. So now that we have undefined, it is either we use factorization method so that we can cancel out the common factors, or we use the L'Hospital. And like I said, now we are going to be using L'Hospital because this is more profitable for objective students. Now, how do I use the L'Hospital? All I simply need to do. Now, likewise, listen, if I impute this value at the numerator, I'm simply going to have 0 at the numerator. That means I will have 0 over 0. This really do not matter. What matters is I am not expected to have 0 at the denominator. So I must do what I can possibly do to ensure that the denominator of this expression turns out to be what? A real value. It exists. It is only on the ground where the denominator exists that you can stop your operation. So sometimes when you are using L'Hospital, you can differentiate once, you can differentiate twice, you can differentiate 3 times, depending on the function that you are dealing, until you get to a point where you have the denominator to exist. Don't stop using the L'Hospital. Alright? So like the factorization method, it has a limit. It can only work for linear or polynomial functions. These are the only aspects where factorization method is useful. But when you are dealing with other functions like trig functions, hyperbolic functions, factorization method may not work. In fact, does not work. And this is the reason why we are using a method that doesn't have limitation to any limit function. Are we there? So now in using L'Hospital, all I just need to do, this is L'Hospital rule. So in using L'Hospital, all I need to do is to differentiate these functions individually. So when I differentiate x, I have 1. When I differentiate -2, I have 0. All over. When we differentiate x squared, we have this to be 2x. And when we differentiate 4, being a constant, we have 0. Automatically, this will have given us 1 over 2x. So now that we have differentiated this function once, then we need to impute the value of x again. If we impute the value of x at the denominator here now, this would have become 2 multiplied by 2, which is 4. Now it exists. That is to say, this is where we will stop. Then automatically, this would have given us 1 over 2 multiplied by the value of x is 2. And our answer is 1 over 4, which is exactly the same thing as 0.25. If that is what you have in your options. Now, we look at question number 2 very quickly. We have that the limit of x squared minus 5x plus 2 all over 2x plus 3. Then I have n tends to 1. So, similarly, the function I have here, like I said, the first thing you do is to identify whether you have a linear function or a quotient function. Now, this is a quotient function where I have a numerator and I have a denominator, so my attention should be on the function I have at the denominator, which happens to be 2x plus 3. So first, I just need to substitute into this denominator to see whether it exists. Now, when we substitute 1 here, we have 2 multiplied by 1 plus 3, and 2 multiplied by 1 is 2 plus 3, and this turns out to be 5. Now that substituting this value into the denominator gives us a real value, we are not going to factorize, we are not going to use L'Hospital, we are just going to substitute direct. Whatever we have here is our answer. You only use L'Hospital or any other method when the denominator turns out to be 0 when you first substitute the limit value that you are given. This is the ground to which you use L'Hospital or any other methods, so that you will be able to make the denominator a defined function. Now, all I need to do here is to have this as. So now that we have validated that the denominator of this expression, after substituting the limit value that we have, it turns out to be a real value, all we just need to do is substitute that. Don't differentiate here. You only differentiate or use the L'Hospital when the denominator turns out to be 0. If this is understood, now let's solve this. So we have 1 squared negative 5 multiplied by 1 plus 2 all over 2 multiplied by 1 plus 3. So if we simplify this would have given us 1 raised to the power of 2 is 1. 5 multiplied by 1 is 5 plus 2. All over 2 multiplied by 1 and the denominator is 2 plus 3. And at the numerator we have 1 plus 2 is 3 and 3 minus 5 would have given us minus 2. And when we add 2 to 3, we have this as 5. This is the answer to this very question, which can equally be negative 0.4 if your answer is in decimals. Are you there? So this is how it is. It is not in every case that you use L'Hospital or factorization method. You only make use of those methods anytime the denominator turns out to be 0 and when you substitute the limit of the function given. Now, let's look at question number 3. We have limit x tends to 3 into x cubed negative 2x squared plus 5x plus 6 all over s cubed minus 8. So now we have question number 3. We have the limit of x tends to 2, 3x s cubed minus 2x squared plus 5x plus 6 all over x cubed minus 8. Again, we have a function that we can liken to be what? A quotient function. Like we have it here that this is a quotient function, right? This is a quotient function. And what do you do when you are given a quotient function under limit? All you do is to concentrate on the denominator. And what do I have at the denominator? I have s cubed minus 8. Now, what is the value of x that is given? 2. All I need to do is to substitute 2 here, raised to the power 3 minus 8. Now, 2 raised to the power of 3 is the same thing as 2 multiplied by 2 multiplied by 2. And 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. This will have given us 8 minus 8. Now, when I remove 8 from 8, I have 0. So, now that I have 0 at the denominator, I definitely know that if I substitute the values direct, I'm going to have it wrongly. So, what must I do to ensure that this denominator is not 0? It's either 1, 2, 3, 4, and above. It can be negative value, but it must not be 0. Are you there? So, what must I do to this expression to have this not to be equal to 0? All I simply need to do is to use L'Hospital rule, where you differentiate each of these functions individually. Alright? So all I need to do is to differentiate this. Having find out that the denominator will be 0 if I substitute the value directly. Then, when you differentiate s cubed, we have 3x, we reduce the power by 1, raise the power 2. Then when we differentiate negative 2s squared, we bring down this power to multiply 2. Then this will have given us negative 4. We reduce the power by 1, we have x raised to the power 1. When we differentiate 5x, we have 5. And when we differentiate 6, being a constant, we have 0. Then we ignore. All over. When we differentiate s cubed, we have 3x squared. And when we differentiate 8, being a constant, we have 0. Then we ignore. Now, the next thing we are quickly going to do, having differentiated this function once, all you need to do is to substitute in the value again. Now, let's test run with the denominator because we are somewhat interested at the outcome at the denominator. Are you there? So, if we substitute here, we are going to have 3 multiplied by 2 raised to the power 2. And when we multiply this out, we will find out that the result here will not be 0. That means we are good to go with this. Now, all I need to do now is to impute the value of x. This will have given us 3 into 2 squared. We are substituting here minus 4 multiplied by 2 plus 5 all over 3 multiplied by 2 squared. So 2 squared is 4 and 4 multiplied by 3 would have given us 12. Negative 4 multiplied by 2 would have given us negative 8, then plus 5. All over. 2 squared would have given us 4 and 4 multiplied by 3 would have given us 12. We have this to be 12. Now the next thing we are quickly going to do here is to what? Simplify the numerator. When we add up, when we remove 8 from 12, we have 4. And when we add 5 to 4, we have 9. This will have given us 9 over 12. Now we find out that 9 and 12 have something in common. And what do they have in common? 3. So 3 into 9 would have given us 3. And 3 into 4 into 12 would have given us 4. So our answer turns out to be 3 over 4. That is like this. As long as the denominator exists, this is the answer to this question. Now listen carefully. If your option is not in fraction, then you can get the decimal value of this. And 3 over 4 in each decimal is 0.75. You can get that done. Now let's look at the last but not the least. We have that a limit of x tends to 2 into x negative 5 all over x squared plus 4. Now also we have a quotient function here, numerator and denominator. And what do? We pay attention to the denominator. Now we have the denominator as x squared plus 4. When I substitute for x, I'm going to have 2x raised to the power 2 plus 4. And when I square 2, I have 4. And 4 plus 4 would have given us 8. So by first substitution, we have the denominator to exist. That means there is no need to use L hospital. If you use L hospital here, you are going to have it all wrong. You can try it out. When you use L hospital, you will not have the same results. So you need to know when to use L hospital and when to solve directly. You use L hospital when the denominator is 0, and you use the direct method when the denominator gives you a real value when you first substitute the limit value or the input value. So all we need to do now is to substitute 2 in place of x. So we have 2 minus 5 all over 2 raised to the power of 2 plus 4. Now 2 minus 5 would have given us negative 3 all over 4 plus 4, and this would have given us negative 3 over 8. This is the answer to this particular question. It's as simple as this. You can equally check your options, and if your options are in decimals, you know what to do to convert this to decimals. So guys, all you need to do is to understand principles. That is all you need to do. Understand principles. When you understand principles, you become a principal. When you understand boundary conditions, you will not overstep your boundary. So if at this point you have not subscribed to this YouTube channel, please do consider subscribing to this YouTube channel and ensure you turn on the post notification bell on reciting videos when we upload it. So see you guys. Don't forget to share this video, like this video, and make your necessary. Love you. See you in